All right, well now we're going to look at two exercises from 3B. These are on page 91. So if you want to follow along, look at page 91. We're going to look at 1A and then 2A, okay? So the first one, 1A, draw a line with gradient 1/2 that passes through the point 0, 3. Okay, so go over to the grid that I prepared. Now sometimes on the paper you'll have to draw your own set of axes, and sometimes they'll be given to you. Let's assume this one's given to us. Okay, the point they gave us was the point 0, 3. So that point has an x-coordinate of 0, putting it on the y-axis. The y-coordinate is 3, so we count up 1, 2, 3, and there's our point right there. Okay, now it says that the gradient should be 1/2. That means the rise over run is 1/2. So if we think of the gradient as 1/2, that's the rise over the run. Okay, so it will go up 1 when it runs 2. So if I go 2 over and go up 1, I'll get another point there. Now, that's 1 point, and you can draw any line through 2 points, but if you do more points, it'll make a better line. So let's go from this point. We'll go over 2 and up 1, and you can do as many of these as you want. And you can do them in the other direction too. If I go back 2, I go down 1, okay? And that keeps it with the same slope or same gradient. Now let's go ahead and draw a line through that using a ruler. You should use a ruler to always draw your lines straight. And as I said, we have seen that in the marking scheme sometimes points are deducted if you don't use a ruler. All right, there's our line. And you can see any 2 points on the line will have a rise and run equal to that gradient. So it doesn't even matter how far apart they are. If I pick these 2 points, which are the furthest 2 apart, and I calculate here, 1, 2, 3, 4, 5, 6, 7, 8. That's the run. And then what's the rise? 1, 2, 3, 1, 2, 3, 4. So rise over run is still 1/2, 4 over 8. And that's the way the gradient gives you information about the line throughout its whole travel from negative infinity to infinity. All right, now let's go on and look at problem 2. Let's remind ourselves what it says. Problem 2 gives us a point, A, and it gives us a point, B. And it says, for each of these point lines, A and B and C lie on the same line. So first we're going to say, what's the gradient of the line through these 2 points? And then we'll find the missing coordinate in point C. Okay, so these are our points 2, 5, and 3, 7. We'll have to remember those as we move forward. Okay, so we're going to plot the points and draw the graph. So the first point was A was 2, 5. So I go over 2 for the x value and up 5. 1, 2, 3, 4, 5. So that's point A, all right, at 2, 5. Now B was the point at 3, 7. Now that is fortunate for us because it only adds 1 onto the x coordinate. So it will go over 1 to 3 and now up to 7. 1, 2, 3, 4, 5, 6, 7. Now why did I say that was so fortunate? Well, the fact is if you increase the x value 1, the value you go up is the gradient. So when I graph this line, and like before, if I wanted to find more points, I'd do the same thing. And this one over 1 and up 2, that really does tell me the gradient. If I go over 1 and up 2, I'll find another point. And I can keep that going. But I always do at least 3 points. And you'll notice when you lay the ruler down, it'll also go through other grid values that are over 1 and down 2. So now when I draw that line, I found point C just because it was convenient to find it. If it's point C, I wanted the x-coordinate to be 4. The y-coordinate will be 7. And this is almost similar to what we did before in sequences and series because we're adding the same amount on every time. We add 2 on every time we increase 1 in the x direction. So I added 2 on to 5 and got 7. All right. I add 2 on, and I wrote 7 down here, but that would actually be 9. If I count it, you'll see that it is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 4, 9. So that works like a sequence or a series, where the arithmetic series has the common difference added on every time. The same thing goes on every time you increase 1, you'll add on the value of the gradient. Okay, so that does 1 and 2, part A.